Welcome to Lesson 13, Bees in the Winter, and our last in the series of the Hobbyist Beekeeping. The three topics that we're going to talk mostly about in this particular lesson are what happens to bees in the wintertime. A lot of people are wondering if they hibernate, they wonder what happens in the hive, and what's really going on in that closed box when it's cold outside. The cluster is a grouping of the bees. They pull together in a group or cluster at approximately 57 degrees. So as the temperature in the hive gets to that level, they start to form this grouping. The outside layer, or the mantle, is approximately 1 to 3 inches thick, and is tightly packed. It maintains a temperature of somewhere between 49 and 57 degrees. The inside layer, or the core, is less tightly packed, but it is critical that it maintains a 90-degree temperature. It's the space in which the queen lives, and that any brood that is in the hive is maintained at that temperature so that it can survive and that new bees can hatch out during the winter months. The bees rotate between these two layers based on hunger, not on temperature. The temperature in the hive is the same as the outside temperature, so the bees do not attempt to keep the whole hive warm. They are only determined to keep themselves warm. In colder temperatures, the bees compact even more, and they get tighter and tighter depending upon how cold it is outside. On the other hand, they always attempt to maintain contact with their honey stores. So in periods of very cold weather, when the cluster is extremely compacted, it's possible that they are not able to maintain that contact with their food supply. So if that cold spell goes on for a long period of time, they actually can starve to death with food in the hive. The slides on this page are a thermal imaging, which shows the interior temperature of the hive, thus the location and size of the cluster. On the left-hand side, the cluster is generating more heat, and it's the sort of red raspberry color. So as you can see in the picture, the larger the red color means the larger the cluster, and it means that they are doing well. As you can see in the other pictures, things are not good. In the bottom one, there is no red, meaning very few bees are left, and probably that hive will not make it much longer. On the right-hand side of the page, there's another imaging that shows the location of the clusters in the hive, the degree of temperature in the different locations, and how those bees are doing in the hive in the winter in this particular circumstance. As you can see from the chart, the size of the cluster, as I said, is a function of temperature. When the temperature is around 50 degrees, the cluster can be 14 inches in size. When it's a little above 20 degrees, the cluster has shrunk a little tighter, and it's about 11 inches. When it gets colder, the cluster, as you can see, keeps shrinking and compacting more tightly to maintain that core and mantle temperature, trying to protect the queen and the brood that are in the hive. But that's an extreme reduction in size from 14 inches at 50 degrees to 4 inches at minus 26. Reasons for failure in the wintertime. There are too few bees in the hive going into the winter to be able to maintain a cluster. Bees die over the late fall and winter due to their normal life expectancy, and in this case, there isn't brood to replace them as there is in the warmer weather. Since they need to maintain a temperature of 90 to 93 degrees in the middle of that cluster throughout the winter, there may not then be enough bees to fulfill that function. They also need to be able to move stores during periods of relative warmth in the winter so they can break cluster, go to where the honey is stored, and bring it into the frames next to where the cluster is. If there's not enough bees that can do that, once again, there's a failure. Not because there wasn't food, but because the food wasn't where the bees could access it. The size of the cluster is a function of temperature. And you can see from the chart that the warmer the temperature outside, the larger the cluster. And that cluster size reduces or compacts in order to maintain that 90 degrees temperature in the center of the cluster as the temperatures outside get colder. Another reason for failure is starvation, not enough food. All bees in a hive will die at exactly the same time, since the feed that's in the hive is shared equally among all of them until the food is gone. So the bees will share equally all the way through until the last drop of honey, and then they will all die of starvation at the same time. The other reason that they can die of starvation is that food is not where it's needed. I mentioned that just a moment earlier. But they will not be able to break cluster in very cold temperatures to access food stores that may be on a frame just one away from where their cluster is. This isn't a problem in very short periods of cold weather. The cluster can survive without accessing their stores. But if that cold period goes on for so long that they've used up all the energy that they have stored, and they must break cluster to get at other food, they will die. Periods of warmer temperatures during the winter allow the bees to break cluster, access stores, move the feed into proximity to where the cluster is. So in winters that have long periods of very cold weather, this is extremely difficult on bees. Another reason for failure in the wintertime is what's called overmanagement of the hive. Under no circumstances do you open the hive, exposing the brood and the bees when the temperature is below 54 degrees. You can lift the top cover and the inner cover to inspect any solid supplemental winter feed on a day that is below 54 degrees, as long as it's not raining or snowing or there's a strong wind or any other adverse weather condition. Try to pick a sunny day with no wind and slightly below 54 degrees and just very quickly look at the feed supplies, making sure there's still enough there for them. Another reason for failure in the hive over winter is a topic that we've talked a lot about through this particular class. Lack of ventilation, which allows for moisture to build up in the hive. The saying is, a wet bee is a dead bee. You need to have airflow with openings both at the top and the bottom. And if necessary, in fact it's recommended, use a super on the top hive body that gives that extra space for feed, for air space, for moisture absorption, and just to give a little more ability for air to move. Make sure your screened bottom boards are not closed off. They could go ahead and get totally blanketed over with snow. That's why that top entrance is important to maintain some degree of airflow in the hive. The entrance can be restricted, but not too much. Instead of closing it off completely to deter mice from moving in, use a screening instead, which allows airflow, but will also keep the mice out. And then, because you've made sure in locating your hives that they're convenient to be checked on, make sure that snow has not blocked the entrance for any long period of time. Another reason for failure of bees in the winter is that they have a compacted digestive tract. And that's just a simple phrase for they have developed a dysentery or a nosema, which forces them to void in their hive. Healthy bees do not defecate inside the hive. They wait during the cold weather until they can make a flight out on a late winter's day that is warm and sunny, and later even in the spring than that. And then they do what's called a cleansing flight. But if you see the fact that bees have pooped or voided on the outside of the hive, you know that you probably have eczema in the hive. The other reason for failure, and once again we've talked about the varroa mite a bit from lesson to lesson in this particular course, and it's a very small, but you can see it with your naked eye, reddish, eight-legged insect. A high concentration of the varroa mite in autumn usually results in overwhelming attack during the winter and the potential death of the hive. Because there's no brood being produced, they take full advantage of the bees that are there and can cause an extreme weakening of the hive to the point of death. So once again, in summary, we discussed the cluster, how bees survive over winter, how they regulate heat within the cluster for hopefully the success of the survival of the queen and the brood. Reasons for failure we reviewed as well. Those include too few bees in the hive to be able to maintain an appropriate cluster and the heat that's required. Starvation, several reasons for that. Overmanagement concerns when you're too busy interfering with them in the cold temperatures. The fact there may not be enough ventilation, and their inability to get out and do a cleansing flight, which may result in eczema, and also the opportunity in the winter for the varroa mite to actually take full advantage of the hive and their proximity to the bees.